It's often easier to multiply and divide in scientific notation as well, especially when you're dealing with larger or smaller numbers. Let's take a look at some examples of multiplication and division in scientific notation. So in our first problem, we have 2 times 10 to the third times 4 times 10 to the fourth. So the way I like to look at these is I will start by multiplying the constants. So 2 times 4 is going to be 8. And then I will multiply the tens using our powers of exponents. 10 to the third times 10 to the fourth, we add our exponents together and we're going to get 10 to the seventh. So in my opinion, that's a heck of a lot easier than counting the zeros and making sure that you don't forget one. Let's look at problem 2. Now we have 5 times 7. 5 times 7 is 35 times 10 to the fourth times 10 to the eighth. We'll add our exponents and we get 10 to the 12th. However, this is not scientific notation as written. This number is not strictly less than 10, so we're going to have to move our decimal point one more over. And remember, when we move the decimal point to the left, we will make the number in the exponents greater. So this final answer is going to be 3.5 times 10 to the 13th. How about this example? Number 3, we have 3 times 2. That'll give us 6 times 10 to the something. We have 10 to the negative 2 times 10 to the negative 3. Negative 2 plus negative 3 is negative 5. This is written in scientific notation, so it is our final answer. Number 4, 8 times 6. That gives us 48 times 10 to the negative 5th times 10 to the 9th. Negative 5 plus 9 will give us 10 to the 4th. But again, just like in number 2, this is not scientific notation, so we have to move our number over, or our decimal place over 1. So that will give us 4.8. And again, we moved it 1 to the left, so we are going to add an exponent to our 10. Couple of word problems here. The mass of a proton is 1.67 times 10 to the negative 27th kilograms. The mass of an electron is 9.11 times 10 to the negative 31 kilograms. So part A says to divide these numbers using a calculator to determine approximately how many times greater the mass of a proton is than the mass of an electron. Let's not use a calculator. Let's just do it ourselves. We can use the calculator to divide our 1.67 and 9.11, but I want to show you how to divide this. So we want the larger value on top. Which one of these is larger? 1.67 times 10 to the negative 27th or 9.11 times 10 to the negative 31st? Remember, we're dealing with negative exponents. So the larger number is going to have the smaller absolute value. Negative 27 is larger than negative 31, so we're going to put that on top. 1.67 times 10 to the negative 27th over 9.11 times 10 to the negative 31st. I'm not going to worry about dividing 1.67 and 9.11 yet. Let's look at our exponents first. What is negative 27 minus a negative 31? Remember, when we subtract a negative, it turns positive. So that's the same thing as saying negative 27 plus 31. So that's going to be times 10 to the fourth. So let's multiply 1.67, because that's the same as 10 to the fourth over 1, times 10 to the fourth. We're going to have to move our decimal place 4 times. 1, 2, 3, 4. So we'll have to add 2 zeros after. So let's put that in our calculator. So this is telling us that a proton is 1,833 times bigger than an electron. (180) 1,833 times bigger. Next question, what is the approximate mass of 1 million protons? 1 million is 10 to the sixth. So 1 million protons, how are we going to figure that out? We're going to take the mass of one proton, 1.67 times 10 to the negative 27th, and multiply it by a million, or 10 to the sixth. We'll add our exponents, and we get 1.67 times 10 to the negative 21st kilograms. What's the approximate mass of 1 billion protons? That's going to be 10 to the ninth. So 1.67 times 10 to the negative 27th times a billion, or 10 to the ninth. Add our exponents. Negative 27 plus 9 is going to be negative 18. So 1.67 times 10 to the negative 18th kilograms. At this point, I'm going to have you stop and work on problem 5, working on multiplying and dividing in scientific notation.